MS Ramaiah University of Applied Sciences.
The title of this experiment is Calibration of a Varnier Caliper using Slip Gauges. This experiment aims at depicting the calibration of a Varnier caliper using a standard slip gauge set. Calibration is necessary for verifying the correctness of a reading as obtained by a measuring instrument. Comparison between a known measurement, which is a standard, and the measurement as obtained by a measuring instrument. It is carried out for a new instrument, a repaired or a modified instrument after the lapse of a specific time period, after a specific number of hours of usage of an instrument, and in other similar scenarios. Slip gauges were invented by Carl Edward Johansson, a Swedish machinist, in the year 1896. Slip gauges comes in the form of a set of small blocks of varying dimensions enclosed in a box. The individual gauges are metal or ceramic blocks, precision ground and lapped to a specific thickness. Two or more slip gauges can be attached or joined to each other using a process called ringing. Ringing is a process where two metal surfaces are joined together by sliding and twisting one surface onto the other in such a way that the surfaces cling together. Whenever ringing is carried out, it should be ensured that minimum number of slip gauges will be used in combination. For example, if one wants to use a slip gauge with dimensions 3.565 mm, for which the standard slip gauge might not be available, the slip gauges 3.5 mm and 0.15 mm have to be joined using ringing to obtain 3.565 mm rather than ringing 3 mm, 0.5 mm and 0.15 mm slip gauges. Even though the reading obtained would still be the same, a Varnier caliper is a measuring scale that lets a user to measure dimensions more accurately and precisely than could be done using a normal linear scale. It indicates where the measurement lies between two marks on the main scale. It is used to measure length, thickness, and internal and external diameters of any object. The least count of an instrument is the smallest value that an instrument can measure. An instrument's precision level is limited to its least count. For example, an instrument with least count 0.1 mm cannot measure the reading 5.05 mm or 10.15 mm. Every instrument will generally have its least count either engraved or embossed over it. A Varnier caliper will consist of a main scale and a vernier scale. The Varnier caliper is read by summing up the main scale reading with the product of coinciding vernier division and the instrument's least count. For example, if the main scale of the Varnier caliper having a least count of 0.02 mm reads 19 mm and 32nd division of the vernier scale is coinciding with the graduations on the main scale, the vernier reading will be taken as 19 mm plus 32 into 0.02 mm, thus giving a final reading of 19.64 mm. There are different types of Varnier caliper available. They can be of analog type, dial type, or digital type. Zero error. Zero error is defined as the level of defect in a measuring instrument. Sometimes the instrument may display some value even when no object is being measured. This incorrect value is known as the zero error of the instrument. For example, if the jaws of a Varnier caliper are completely closed and is just in contact with each other, and the instrument is showing a reading of 0.1 mm, then the zero error for the vernier is plus 0.1 mm. Zero error of any instrument should always be compensated or offset while taking the final reading. Zero error for a measuring instrument should always be identified and subtracted from the measured reading to obtain the actual reading. For example, if a vernier gives a reading of 15 mm and it has a zero error of plus 0.1 mm, then the actual reading is obtained by subtracting the zero error 0.1 mm from the obtained reading 15 mm, which is 14.9 mm. The apparatus required for carrying out this experiment are a vernier caliper which is to be calibrated and a standard slip gauge set which is the calibration standard. Here goes the procedure for carrying out this experiment. Select a standard individual slip gauge of any dimension. It should always be ensured that the slip gauge set being used is calibrated by verifying the calibration certificate and its validity. Wipe the ground surfaces of the slip gauges using a clean cotton cloth in one direction only to ensure that the slip gauge does not have any dust particles over the ground surfaces. Do not wipe the ground surfaces back and forth as it may lead to scratches over the ground surface. Ring two or more slip gauges on their respective ground surfaces to obtain the required dimension using the minimum number of slip gauges possible. Clean the lower jaws of the vernier caliper with a clean and soft cloth. Place the rung slip gauge blocks between the lower jaws and hold it firmly such that the surfaces of the slip gauges is parallel to the jaws. Read the value shown in the instrument and record it. Compare the value measured by the instrument with that of the value etched upon the slip gauge. In ideal case, both the values must exactly be the same. Repeat the procedure by increasing the value of slip gauges pile and then decreasing the value of slip gauges pile. Tabulate the measured readings. The readings obtained must be tabulated in the format of a tabular column. Carry out the calculations using the standard formulae of reading a vernier caliper and find the error in reading as well as the sensitivity value of the instrument. 3 graphs have to be plotted after tabulating the readings in the tabular column. They are slip gauge combination reading versus average of the vernier readings, slip gauge combination reading versus error obtained, average of the vernier readings versus the correction required. This experiment has its own limitations. The calibration of slip gauges cannot be ensured and is completely based on the available calibration certificate only. The experiment does not take into account that the slip gauges might have worn out or its accuracy decreased due to usage. It requires a spick and span working environment. Tiny dust particles can also lead to wrong reading from the instrument. This concludes the experiment calibration of a vernier caliper using slip gauges.
Hello students, today we are going to see an experiment on how to calibrate a vernier caliper. Calibration is a process of verifying the accuracy of a reading obtained by a measuring instrument by comparing it with a known standard. The apparatus required for carrying out this experiment is as follows. This is the vernier caliper. This is the standard which is known as a slip gauge set, or it is also called as the gauge block set. The standard slip gauge set consists of 87 slip gauges having a minimum length of 1.001 mm and a maximum length of 100 mm. The length of each slip gauge is shown over here and each slip gauge is placed in their respective slots. Slip gauges have a unique property that two or more individual slip gauges can be attached with each other on their ground surfaces to form a single block using a process called ringing. Two or more slip gauges have to be run to each other to obtain a measurement which is not available in the standard set. Now we will see the procedure to carry out the ringing of two or more slip gauges. Now we will see the ringing process of two slip gauges, 100 mm and 70 mm. As you can see, each slip gauge will have two ground surfaces at its opposite ends. Ringing has to be carried out only on the ground surfaces of the slip gauge. The first step of the ringing process is to clean the ground surface which is to be run on the other slip gauge using a cotton cloth on one direction only. The ringing process has to be begun by holding the two ground surfaces perpendicular to each other in this manner. Now slowly slide one ground surface over the other ground surface until it reaches its mid position. Apply a slight force and twist one of the ground surfaces over the other such that both the ground surfaces get rung onto each other. Now you can see that the two slip gauges have been rung onto each other. The two slip gauges 100 mm and 70 mm are now a single block measuring 170 mm. Similarly, few more slip gauges can be rung onto the same set as per the dimensional requirement. Now we will see how to calibrate a vernier caliper using the slip gauge set. As you all know, this is a vernier caliper. The parts of a vernier caliper are the lower jaws, the upper jaws, the lock nut, the main scale, the vernier scale. The graduations on the vernier scale are in mm. The range of this vernier caliper is 0 to 200 mm. The least count of this vernier is 0.02 mm. Now we are going to start the calibration of the vernier caliper. The calibration will be done with respect to the rung slip gauge. Similarly, we have run two more slip gauges, 5 mm and 5.5 mm to form a dimension of 10.5 mm. Now we are going to calibrate the vernier caliper with respect to the standard 10.5 mm slip gauge. The calibration starts with measuring the 10.5 mm slip gauge set with the vernier caliper. Hold the slip gauge set and pull the lower jaws of the vernier caliper using the slider of the vernier. Now lock the slider of the caliper using the locking screw. Since the caliper has been locked, remove the slip gauge and take the measurement. Now you can see that the main scale of the vernier is reading 10 mm and the 27th division is the coinciding vernier division. Thus the reading of the vernier is 10.54 mm. Now we have completed the first trial of readings for the calibration of vernier caliper. Similarly, increase the pile of slip gauges using ringing and take different readings. After tabulating the readings, plot the graphs and calculate the percentage error. This concludes the experiment calibration of the vernier caliper using a standard slip gauge set.
At MSR UAS, we spark your imagination unlike any other.